Okay, how's everybody doing today? Doing all right? Good, good. I'm doing fine. Okay, we will continue with review 5 in just a moment. A couple things. You've got review 6. Okay, I'd encourage you to go ahead and take a look at that. We'll be looking at that next week as we continue. Maybe even be able to start it today, kind of depending on how long it takes us to finish up review 5. But don't forget, there's also on the website, I reposted the link again to the OSC site that has all those different problems, the easy, medium, hard. It's got the video explanations, all that stuff. Is anybody taking a look at that? A little bit. Okay. It is there for you guys. On Monday, we are going to have your second exam. Now, I did post the 6 problems. So it's going to be one of these 6 problems from last year's paper 2 exam. 2 of those are the test on Monday. Okay, so we got all different kinds of topics here: chi-squared, probability, currency exchange, good old algebra, derivatives. Okay, has anybody had the opportunity to start looking at those? Okay. If you have the time, okay, they are available. I went ahead and posted them to the website. As far as today goes, remember, I'm going to be staying after school today. We'll probably go ahead and start maybe 4:10, definitely by 4:15, just to give everybody the opportunity to show up. I do have last year's paper 1 exam printed, ready to go. You'll have your own copy, 90 minutes. We'll run it just like what's going to happen on the 13th. Okay. How many people are planning on showing up? Okay, a few folks. Okay. All right. Well, we will be here. Hey. Yes, if you're not able to come today, just let me know and I'll give you the paper. Okay. And probably on Monday is when I'll go ahead and post the mark scheme for it so you can start taking a look, see how you did. If you have any questions, come ask me. And we could probably even talk about it next week. I think that's all I got. Unless anybody has any questions about what's coming up. Okay, then let's keep going here. We were going to go ahead and start number 8 yesterday, but we stopped because we didn't have the grid. So you have plenty of grid paper. In fact, if you want to take 2 or 3, even to help you with, review 6, I know there's several graphs that you need to sketch on that one. You are more than welcome to take some of those. Let's see here. On the same axes, sketch the graphs of y equals 2 to the x and y equals 3x for x between -1 and 4. Okay, so let's come on over here. Okay, so we have y equals 2 to the x, y equals 3x. Make sure I got those correct. Okay, 2 to the x, 3x. I want to get between -1 and 4. Okay. Okay, so I would just say let's go ahead and create a table for each of these and then go ahead and plot our points and see what ends up happening. Let's start with the exponential. So x, we have 2 to the x. Okay, and we're wanting to go between -1 and 4, so I'd say probably just the integer values would be more than enough. So -1, 0, 1, 2, 3, 4. Go ahead and extend that a little bit. And then we'll go ahead and create one for 3x. Okay, there we go. So that would be, -1, 0, 1, 2, 3, 4. All right. Okay, now we've talked about this before. If I were to plug in a negative value and I had a negative power, how do we deal with that? So if I plug this in and I have 2 to the -1. There you go. You go ahead and make it a fraction. You take the reciprocal. By taking the reciprocal, that makes it positive. What's anything to the 0 power? That's 1. Okay. And then 2 to the first, 2 squared, 2 cubed, 8, and 2 to the fourth, 16. There we go. So good little exponential graph there. And then 3x. So let's see here. All I got to do is triple it. So just go straight down the line and tell me what we got here. -3, 0. There you go. And you'll notice, depending on the function, it's linear with the slope of 3. So you'll notice it's just increasing by 3 because we have consecutive values for x. Same thing over here with your base being 2. You can see that's the factor that you're using over and over again. So remember those patterns as you're looking at these. Okay, so it looks like the highest y value I need to get is 16. And the x I only need to get to 4. Okay, so let's go ahead and say we're going to do this a little differently here. Let's see. Because we're starting at x equals -1, why don't I go ahead and do this. There we go. Okay, so we'll have -1, 0, 1, 2, 3, 4, and vertically we got to get up to 16. I don't think we have enough of those. 1, 2, 3, 4, 5, 6, 8. Yeah, I don't have enough of those. Maybe go by 2s. 2, 4, 6, 8, 10, 12, 14, 16. Perfect. Okay. All right. And now another super exciting part of the lesson, plotting points. All right, so -1 gives me 1/2. Okay, so -1 gives me 1/2, so maybe right about here. Okay, and then we have 0, 1. Then we'll have 1, 2, 2, 4, 1, 2, 2, 4. Then we got 3, 8. And then we'll finish it up with 4, 16. Okay. So there's my exponential. Okay. And then 3x, looks like we have -1, -3, so that's going to be a little off our graph. I'm not going to worry about that. Then we have 0, 0. Then we're going to have 1, 3. Okay. And then we're going to have 2, 6. What else we got? 3, 9, and 4, 12. So 3, 9, and then 4, 12. Ooh, so my curve is not perfect. Okay. 4, 12. Let's say that right there. Okay. And I'm going to do this. Make that as straight as possible. And then I'll just like that. Okay. So there's 3. Okay. So I'm ending up with something that looks like that. Okay. And I don't have the paper in front of me. Do you want me to do anything after that? What are we doing here? Okay, so graph them on the same axes. Solve 2x equals 3, 2 to the x equals 3x, correct to 4 decimal places. Okay, so now we need to go ahead and solve this. Now, this is one of those times where I would encourage you to go ahead and use something that we talked about on the calculator. Okay, I'd go ahead and say numerical solve. I said that's probably going to be the best way to go ahead and get this taken care of. So let's see here. How do I get there? Menu. Okay, was it number or algebra? Algebra. And then numerical solve. Right, there we go. So 2 to the power of x. Okay, let's get out of there. Equals is right below control. Then we have 3x. But with numerical solve, you have to do something. Comma x. So I'm going to say comma x and then enter. Okay, and it said 4 decimal places. So 0.4578 is what I would say. 4578. Okay. Now that's one of them, but do you notice something? When you're looking at the graph, what do you say? So that would definitely go ahead and correspond to that one right there that we found. But then we also have a second one, right? Okay, so what I would probably go ahead and do, because the numerical value, or numerical solve, excuse me, just went ahead and gave me the 1, bless you. Okay, I would also use this technique, or maybe just go ahead and use this in place. I'd go ahead and just graph them. If it'll let me do this. So 2 to the power of x. There's that curve. And then we know it's restricted. I'm just going to go ahead and see the entire graph. Let's see here, tab 3x. Okay, I'm just going to need to extend my window a little bit so we can find that one, but it's going to be the 0.4578. Let's see here, window. Instead of zooming out, why don't we just go to window settings? Because really all I need to do is change this one right here, the Y max. Oh, Let's say 20. Not 520, 20. There we go. As long as I'm able to see that intersection. So let's move him out of the way here. Let's move him out of the way. Now, how do I find the intersection if I'm looking at it graphically? Menu. Analyze graph. Intersection. Okay. Now, remember, the lower bound means I want to put this vertical line just to the left of where I believe, or the point is that I'm trying to find. So then you push enter, it'll lock it in place. Upper bound, I'll just sweep it across. Okay. And I'm not remembering off the top of my head. I don't know if any of you guys do. Does anybody know how to go ahead, because it wants the 4 decimal places. How would I go ahead and extend that? Honestly, I don't remember how to do that off the top of my head. I know there's a way, but I don't remember. Does anybody ever done that before?
I think it has 4 decimal places.
No?
Because I clicked on it.
Did it?
With text.
I'll look into that. I'll ask Mr. Heinrich about that just to be on the safe side. So for right now, we'll just go ahead and say, what was it, 3.31? Okay.
Why is it that intersection?
What's that, ma'am?
Like there's 2 intersections.
Mm-hmm.
Why does it?
Well, we're using both.
Yeah, we're finding both.
Okay.
Mm-hmm. Yeah, the calculator, the numerical solve only gave me one of those. That's why that's also, it brings up a good point, because remember, when you're looking for, say, the roots of a quadratic, if you go ahead and plug that into numerical solve, it'll give you one of them, but it won't give you both of them. Yes, ma'am?
So on the test, will it specify whether or not it wants 1 or 2?
Well, because it says to solve, it probably went ahead, they probably went ahead and had you sketch it so that you could see there were 2 solutions, so that you knew there were 2 you needed to give. That's my guess. Yes. So for this one here, actually, my graph even turned out pretty nice, because that is halfway between 3 and 4. Okay. So that sketch turned out pretty cool. All right. So what was that? 3.31? Okay. All right. So let's see. I think the other one was 0. What was it? 4578? Okay. And then the other one, 3.31. Okay. Let me look into that and see if I can figure out. I thought there was a way you could expand that, but I'll see. Okay. Any questions on number 8?
So when it says like solve equation equals equation, just like.
Oh yeah. Really, graphically, that's what you're doing every time you have an equation. You could just solve it algebraically or any method.
So that's just finding the intersection.
Yes. Basically, you're just finding the values of x that make it true. All right. Well, let's see. Number 9. We got triangle ABC. It says calculate length CD. So I want this guy right here. Okay. So let's see here. Who haven't I talked to? How about Sierra? How would I find that length CD? What can I do? Pythagorean theorem? No, I can't use the Pythagorean theorem because I've only got one side here. Now, if this were maybe a 30, a 60, or a 45, maybe I could use, a special triangle, but I'm thinking more a trig function. Because think about it, we have 50 degrees here, we know angle A. The side that we're trying to find, what would that be with respect to 50? The opposite. So we have the opposite side, and we also have the hypotenuse. So what trig function uses that ratio? Sine. Okay. So I'm going to go ahead and say sine of 50 degrees is equal to the opposite, what we're trying to find. So I'll go ahead and say CD over, what do we got here, 8 centimeters. Okay. And then how would I figure out this equation? How would I figure out CD? Yeah, I just multiply through, get rid of that fraction. So 8. Those are going to cancel. So I just need 8 sine 50. Let me go ahead and get out of here. Okay. So 8 sine 50. Okay. Hey, if I can push that button. There we go. All right. So I'd probably say maybe 6.13 centimeters. Okay, go ahead and say 3 sig figs. 6.13. All right. 6.13 centimeters. Okay, and then it says calculate the length dB. Okay, so 6.13. Okay, so now I would probably go ahead and do what? I'd probably use Pythagorean theorem. Okay, so Pythagorean theorem, if I'm going to use what I have, I would say dB squared plus the 6.13 squared is equal to 10 squared. Okay, so I'm just going to rearrange this a little bit. dB squared is equal to 10 squared minus the 6.13 squared. And then in order to find length dB, we'd have to do what? Square root. There we go. So let's see what we got here. So I'm going to go ahead and do this. So square root, I'm just going to go ahead and plug in 100. Whoa, what was that? Okay, weird. Okay, I'm going to plug in 100 minus parentheses, and I'm just going to use the approximate value here. Okay. So I'm getting that length to be about 7.9. Okay. Here we go. Okay. All right. Questions? Easy, right? Nothing too bad. Okay. All right, number 10. Find the equation of the line joining 410 and 74. Okay, so it doesn't say what type of equation. We just need an equation. But any equation, a straight line, needs something that's really important to it. Slope. Okay, we need that first. So let's see here. My gradient is going to be the change in y over the change in x. Okay. So it doesn't matter. Let's go from B to A. So 4 minus 10. Okay, the difference of the y's, but I'm going to go in the same direction. The difference of the x's, 7 minus 4. So it looks like I'm going to have negative 6/3. So the slope is negative 2. Okay. So why don't we go ahead and do a problem like we did recently? We'll go ahead and use point slope to get the equation, and then I'll let you guys decide, do we want to go ahead and put it in slope intercept form, or do we want to do like they did the other day and put it in standard form, where A, B, and D are just integers? Okay. So first we need to decide which point we want. Evelyn, what point do you like? A or B? A. So I'm going to use the point 410 with the slope of negative 2 that we got. So let's see here. Alejandro, what is the point slope form with that information? Point slope form is y minus y1 equals m times x minus x1.
Y minus 10.
Okay. Perfect. Okay. And Michelle, what do you like? Do we want to go ahead and put this in slope intercept or standard form?
Can we do both?
You want to do both? Yeah, sure. Okay. All right. So let's see what we got here. First off, I'm going to have to distribute no matter what. So y minus 10 is equal to, what do I get if I negative double that?
2x plus 8.
Okay. And then all I got to do is add the 10 over. So y equals negative 2x plus 18. Okay, well, there you go. And then over here, let's see, I'm going to go ahead and copy that first step. So y minus 10 equals a negative 2x plus 8. So I'm going to want to pull everything to the other side. If I add 2x, I'm going to have that, plus the y, but then what's my constant? Negative 2? 18 is equal to 0. Okay. All right. And that would be their version of standard form. But luckily, everything still fits all the rules that we talked about. Okay, question. How are we doing? Okay. We feel ready to take on the test? We could take it right now if we could. For sure. That's what I like to hear. All right. Okay. Well, let's continue. Number 11. A class contains 9 girls and 7 boys. If 2 students are chosen at random, find the probability that both are girls and one is a boy and one is a girl. Okay. Now I know probability is one of the methods we've been working on lately. It was a difficult concept. Do you want me to give you about a minute to try this one on your own? Okay. All right. In fact, while you guys are looking at that, who will not be able to come by today after school? Okay. Oh, 2, 3, 2, 2. Okay, there we go. All right. Now remember on these, you are allowed scratch paper, but as Ms. Moore was telling you when she was in here last time, they want everything done in the test booklet in pen. Okay, especially all your work shown in pen, your answers. The only thing that is acceptable in the examination booklet that's in pencil is if they ask you to sketch a graph. Then you could go ahead and use a pencil, but everything else must be done in pen because it's scanned before it's sent overseas, and pencil doesn't come up very well. They like pen. Yes?
Honestly, mine's a silly question, but when you guys guide calculators, if you take the test,
Yes.
I think should it.
I mean, you can. We just have to make sure that it's, cleared before we go ahead and get started. But yeah. Mm-hmm. All right. So on your scratch paper, I mean, you could write in pencil as much as you want. And then I've seen some people go ahead, they did all their work, on the scratch paper, and then they wrote in pen, because in that big box, if you go ahead and start flipping through the test, like right here, I mean, the very first problem, it's got a whole box to show your work. And remember, definitely show as much work as possible because they can always give you credit for that. But then there's always going to be that tiny little box that has the answers. And that's where the final answers are going to go. Okay. All right. So any work needs to be within that box. That's all they're going to be looking at. Okay. Let's see number 11. Class contains the 9 girls. I'm not going to read it again. Hey. Oh, yes.
How many questions are
Paper 1 has 15 problems and paper 2 has 6. Both of them are 90 minutes, and you can use a calculator on both of those, both exams. Okay. All right. Okay, so somebody help me out. What do I do to figure out the probability if 2 students are chosen at random that they're both girls? You could create a tree diagram. Okay, so how would you like me to create that? Like boy and girl. Okay. Boy, girl. Okay. And then from that again, I could go boy, girl. Okay. All right. All right. So, what are the odds of picking a boy?
7?
Okay, 7/16. And then we have 9/16 because there were 9 girls. And remember, when you're looking at the diverging branches here, their totals should be what? 1, because that represents 100% of every outcome that could possibly happen. Okay. So let's see here. If I chose 1 boy, then that means there's 6 boys left out of 15. So 6/15 would be 2/5. Okay. So that means there should be, if I chose a boy but then a girl, okay, 9/15 or 3/5. Okay. I'll just go off the sum that they have to be 100. Okay. And then if I chose a girl but then a boy, so that would be 7/15. Okay. So that would be 8/15. Okay. Perfect, perfect, perfect. So we're wanting 2 girls. So let's see here. If I choose a girl and then a girl, there we go. So I'm going to take 9/16. And what am I going to do with the 8/15? There you go, 8/15. Because remember, when we've talked about these tree diagrams, the branches that have the outcome you want, those are what? Those are the intersections. Now, if more than one branch has my outcome, we add those, that's the union. Okay, so let's see here. Instead of multiplying those big numbers, let's see, 9 and 15, that would be 3, that would be 5, that's 1, that's 2. So I'd say 3/10. How many people got 3/10? Perfect. Okay. One boy and one girl. Okay, the branches that fit that. Okay. Let me take this off right here. Let me go ahead and use another color. Okay, so we could choose a girl and then a boy, or we could get a boy and then a girl, right? Is everybody okay with that? So there's two branches here. So I would say 7/16 times 3/5. And then we just talked about it. We're going to add the product of the other branch, 9/16 and 7/15. Okay. Unfortunately, this one's not going to reduce, so that's going to be 21, was that 80? 21/80. Okay. Plus, now this one will reduce, so let's see if that helps me out. 3, 5, haha. Plus 21/80. So it looks like I'm going to get 42/80. And what would that become? 21/40. Okay. What do you guys think? Okay. How many people got that right? Okay. What can I do to help? Is everybody able to follow along what we did, how we got the values? Only two branches, yes. Because the other two are either going to give me two boys or two girls. All right. Everybody's good? Okay. If you do end up having any questions, just let me know. Okay. All right. 12. How many we got here? 16. Okay, so we're getting close. Ooh, it's already 1:51. Man, time flies when you're having fun. Okay. Shopkeeper has a bundle of X 20 euro notes and Y 50 euro notes. There are 27 notes, and their total value is 840 euro. Write down two equations involving X and Y. All right. Okay, so one of these is going to revolve around the value. The other one's going to revolve around just the number of notes that I have. Okay, who can give me either? Okay, Samir, what do you think? Perfect. X plus Y equals 27. So there are 20 X notes, there are 50 of the Y notes, there's 27 total. Okay. Well, the value, sorry. And then now the other equation is going to be based on the value. 20X plus 50Y equals my 840. There you go. So I have my system. Okay. And again, remember we solved one of these by hand the other day. I think we used elimination. Okay. Substitution. We also talked about inverses. Would you like to solve it by hand, or would you like to use the calculator? Calculator? Okay. So let's see here. Where do I go again? Menu. Oh, it's doing the green dot, so let me go back over here real fast. Click that mouse button. Okay. So menu, algebra, solve a system. Okay, and default two equations, X and Y. So we have X plus Y equals 27. And the other one, what was it, 20X plus 50Y? 50Y equals 840. Okay. All right. And then looks like we have 17 and 10. Ah, I got close again. Was it this class that it actually happened? Where I actually got my 1738? There you go. That was a good day. 1738. All right, so x equals 17 and y equals 10. That's right. And I'm not worried about writing it today, but I think it was Samir who brought up a good point the other day. Don't forget about your units. Okay, like, if you're talking currency or if you're talking measurement, degrees, whatever that may be. Okay, don't forget to put those down as well. Has anybody had the opportunity to look at mark schemes? There have been cases where they do take off for that if you don't put that. Okay. All right. So let's see here. 13. G of x equals x squared minus 6x plus 10. What does it mean find g prime of x?
That's our prime for the derivative.
There we go. Okay, so what's the power rule tell me to do? Or what would the derivative be? Okay, so g prime of x is equal to 2x minus 6. For what values of x is g prime of x greater than 0?
So we just have the equation equals 0 and solve for x.
I would say so. I would probably go ahead and actually make an inequality. Go ahead and...
Well, that's what I was saying is we could solve it.
Uh-huh.
X value would make me consider then do x, all values of x that are greater than whatever.
Oh yeah, I mean that would absolutely work. Yeah, absolutely. So I'm just going to go ahead and replace it. 2x minus 6 is greater than 0. So 2x is greater than 6. So this tells me x has to be greater than 3. There we go. Now think about what it's telling you if you were to look at the graph. When it says this function is going to be greater than 0, that means what? Okay. Well, that's true. It can't equal 0, but I'm talking about what part of the graph is it looking for? It's above what? What represents 0 on the coordinate plane? The x-axis. So we'd be looking for the portion of this graph that was above the x-axis. That's where it's greater than 0. Okay. Of course, less than 0 would be below. Okay. All right. 14. Find the coordinates of the point on y equals x squared plus 2x plus 5 where the gradient is 10. Okay, so how do I do this one? Hey, Emily.
Well, set it equal to 2.
I will set it equal to 10, but not the original function. To the derivative, because it says where the gradient is 10. Okay, so what's the derivative of x squared plus 2x plus 5? So 2x plus 2. So that's what I'm going to set equal to 10. We want the value of x that would give me a tangent line with that slope. Okay, so this is a two-step equation. 2x is equal to 8, so x equals 4. Now, am I done? No. Find the coordinates. Now, do I plug it back into the derivative or the original? The original, okay. So let's see here. That would be 4 squared plus 2 times 4 plus 5. Huh, 4 squared 7 years ago. I don't know. I just kind of thought of that one. That's how my mind works. So what do we have here? 16, yes, plus 8 plus 5. That would be 29. So we should have a tangent line with a slope of 10 at the coordinate 4, 29. There we go. Everybody okay how I got that? Hey, Emily. I would probably think it'd be preferable to write it as a coordinate because they're looking for that location. All right, and we're almost done. 15. A woman puts $3,000 in an account which gives 4.25% interest compounded annually. How much interest to the nearest dollar will she receive after 3 years? Okay, so we got to remember that formula.
So is it 2 of 1?
Oh, now you're thinking arithmetic and geometric sequences.
Just the first term times 1 plus the
Yeah, I guess you could do it that way. I was thinking more, do you guys remember the formula? Like, you have your initial amount, and they probably use a different variable because it's been so long, but then you have 1 plus, remember it was R over 100 K, and then that was to the power of, oh, no, well, and IB had a slightly different formula. They said K N. Okay. So I might be off on the initial amount variable. I don't know. Well, remember, R is your interest rate. K is what? That's the number of times per year you're going to compound it. N is the number of years. Okay. So here, this is my value of A. This is my R. Okay. It's compounded annually, so that means K equals, what? Oh, I heard 1, I heard 12. 1. Annual is just once a year. Okay. Well, remember, that could be anything. It could be monthly, weekly, daily, biannually. Okay. And then N is going to be 3. Okay. So let's see. We have 3,000 times 1 plus the 4.25 divided by 100. And then we're going to raise it to the power of 1 times 3, so that's 3. There you go. And remember, this was unusual. You might remember way back in algebra or algebra 2 when you were taught these, you had to move the decimal over, but this formula here kind of takes care of that for you. Okay. Hey, Eli.
Well, can we even, so it's kind of compared up to other things. So can we just do that formula and instead of, and just raise it to the power of the amount of times it's compounded, essentially?
Yes. All right. So let me see what we got here. Document B, 3,000. 1 plus control divide. Was it 4.25? Over 100. And then we're going to raise that to the power of 3. Okay. So I'm getting $3,398.99. But it did say to the nearest dollar, so $33.99. So 3,003. Oh wait, did it say the interest? Oh, how much interest? Oh, you're right. Okay. So what I want to do is subtract the 3,000. Okay. Yes. Oh, I was trying to throw a curveball at you to see if you would catch it, and Haley was on top of it. Okay. See, it makes you feel so good. She's going to do that Minnie Mouse impression or Mickey Mouse impression. You can't be embarrassed. You're wanting to be an actress.
That's true.
What?
I don't think so. What if we paid you?
Yeah, I'm kind of curious. How much would you give her to do that?
I have $3 right now for you.
You've been spending too much time in here, Eli.
What? My high fives were great, sir.
So $339. There we go.
$3.99.
What? See, I'm so thrown off by the fact that Haley will not do a Mickey Mouse impression.
You're killing
It's just destroying my world. I did a horrible impression yesterday of a British person. Eli.
Will we be given the compound interest formula?
That is in the formula booklet, yes. That is. All right. Okay, 202. Let's see how much further we can get. After how many complete years would her investment first be worth more than $4,000? Okay. So what variable are we trying to solve for? N. Okay. Let me go ahead and put this down here. So I'm going to set my equation equal to 4,000 equals. Okay, so she invested 3,000. So it looks like everything's remaining the same. So we have the 1 plus 4.25 divided by the 100. And all we know now is that it's going to be N. Because K is still 1. Okay. Again, I'll let you guys decide. We could use numerical solve on that. There is only going to be one solution. We could run through it by hand. Okay. Where you will have to use a logarithm. And then you'll have to turn to the calculator anyway. What would you guys like? Just do the numerical solve? Okay. All right. So let's see here. Menu, algebra, numerical solve, 4,000 equals 3,000. Okay. Parentheses 1 plus control divide 4.25. Yep, yep, yep. 4.25 over 100. Okay, we're going to get out of there to the power of x. Okay, and last up, comma x. All right, so it looks like I typed that in correctly. What should I be getting? Okay, 6.91. Okay, now it does say after how many complete years be more than 4,000. Okay. So what do you think I should put as an answer? 7. 7 years. I don't know. Does that seem worth it to wait 7 years to get $1,000? Yeah. Yeah, it's true.
It's just money you want.
Yeah, it's your money. Use it when you want it.
And it's free money.
But, Mr. West.
Yeah, because I mean, well, if you spend it, then your money's gone.
Well, you're not spending it, it's just-
But yeah,
It's not free either, because you have to, like, you're basically spending that.
Well, yeah. Well, so
Yeah.
here's what you could do. So invest the money.
yes.
Tell your friend you invested the money, and have them use one of those Men in Black machines on you. That way you don't know about it, and then they tell you after 7 years, like, hey, by the way, you have $4,000. You just didn't pull that.
Hey,
And that's a pretty happy day.
there you
I'm
go.
having trouble following scientific validity of this.
Nice. All right. Okay, I got 205. We are down to our last problem. Do we want to try and wrap it up? Do we want to go ahead and just stop for today? You want to continue? Okay. The fast problem? Okay. So 16. All right. So Haley just said if we can get this done before the bell, she will do her impression. Okay. 12, 3x, 5, 7, x, 2x. The mean of these numbers is 8. So what do I do? There you go. Find the average. So 12 plus 3x plus 5 plus 7 plus x plus 2x. I divide it by 6. So that average should be 8. Okay, so I know that this sum should equal 48. See, all I did was go ahead and multiply through by 6. Okay. So let's see. It looks like I'm going to have 6x, 12, 19, 24. Okay. Plus 24. 6x is equal to 24. 48 minus 24. So x is equal to 4. Okay. So that means this is really 12. This one's 4. Let me get rid of this 7 years. And this one is 8. Okay, so let's go ahead and put this in order. So 4, 5, 7, 8, 12, 12. Now, what do I do if there's an even number of terms, but I need the median?
Find the middle of the middle two numbers, or find the average.
Find the average of the middle two. Okay. Okay, so 7 plus 8 divided by 2, 15 halves, 7.5. There we go. Okay, we finished before the bell. That's messed up. You know, I do have another impression I can help you out with. I'll show you another impression if you show me this one. This is going to become my cause. There you go. Okay. I do a great impression of a cat about to yak a hairball. Okay, so now you got to listen. You got to listen. It's got to be like super quiet. Haley. Oh my gosh. Okay, yes, Louis, your question.
So, what do you multiply by 6?
Oh, I'm sorry. Because we wanted to go ahead and get rid of the fraction so that we could solve the equation. Because if I multiply by 6, those are going to cancel. So this equaled to 48. Nothing. Oh my God.